Welcome to SQL Injection tutorial video. In this video, we'll dive into a SQL injection. You'll learn what it is, how it works, and why it possesses a serious threat to applications that rely on databases. Whether you're a developer, security professional, or ethical hacker, understanding SQL injection is crucial for securing modern web applications. We'll break it down with real-world examples, hands-on demos, and simple explanations to make sure you grasp both the theory and the attack techniques. Let's start by understanding the fundamentals before jumping into exploitations and preventions. Structured Query Language, or SQL, is a language that is used to communicate with the database in an application. It allows you to create, read, update, or delete data in the database. Here's a very simple example of a database. Our table has a table name, which is students. As shown here, the students table includes multiple fields, which are student ID, first name, last name, and major. Normally, the database has a primary key field that is unique and is used to identify each value. In this example, it's student ID. Let's see some SQL example queries. The first example is a select query to retrieve data from the database. This query aims to retrieve the major for a student with ID 100. Another query aims to insert data into the database. You can see that we have defined a new student and specified all the fields in this databases for the new student. SQL injection attack is an attack where the attacker attempts to manipulate queries to the backend database and thus gain some level of privilege, which can be reading, writing, modifying, or even deleting data. This in turn compromises the CIA, which is confidentiality, integrity, and availability of data. SQL injection can also be used to exfiltrate data from the database using various methods. I will be creating more advanced videos in SQL that will be covering data exfiltration. Depending on the database configurations, the attacker may even be able to run OS commands and thus gain remote command executions by exploiting this vulnerability. The main trigger for this vulnerability is passing untrusted data, which is the data provided by the user, directly to the database or using it to construct a database query. Let's see an example Python. As you can see here, we first read student ID and put it into the input variable, and then we construct a query using the user provided input, which is then passed to the database. Okay, so now let's see at a high level how SQL injection works and what parties are involved. As shown here, the attacker sends a payload to the vulnerable web application, which is then passed to the backend database. The database, of course, is internal, meaning that it's not accessible to the public internet. In a very simple scenario, the output is then sent back to the attacker, but it depends on the type of the attack and a few other factors that we will cover in this video. Now that we have discussed some of the core concepts, next comes the methodology. In other words, how to find SQL injection vulnerabilities. The common entry points for SQL injection are form fields, query parameters, and headers. Form fields are, for example, login forms or a search feature or any input submitted in a post request that potentially is passed or rendered by the database. For query parameters, consider this example that we provided here. Here you may be able to change the number to and perform SQL injection. The important point is that the value after ID is passed to the SQL database. For instance, the SQL query might be to select all pages related to a user with ID 2. Another potential entry point is HTTP headers. Sometimes developers create SQL queries using the values in these fields, for example, the referrer header or the user agent. When it comes to SQL injection, one of the simplest tests is to use a single code to see how the server responds. If you see an error, it's clearly showing that there is a potential for SQL injection. It is worth noting that the real world scenarios might be more complicated than just simply testing with a single code. This single code breaks the query syntax because of unescaped code. Now let's see why the single code works. In the first query on this slide, you can see a normal SQL statement. It's properly constructed and everything works as expected. In the second query, there is an extra single code, which causes a syntax error because the SQL query becomes incomplete. In the third query, I demonstrate how this can be used to inject a malicious payload, which is identified by red. After the username, we insert a single code to close the original string, then add an or 1 equal 1 condition. This means the query will return true if the username matches or if 1 equals 1, which is always true, effectively bypassing authentication. This example shows in simple terms why the single code works. It breaks the intended query structure, allowing the attacker to insert arbitrary SQL logic. Okay, so let's discuss different types of SQL injections. In general, we can categorize SQL injection types into three main types: inbound, blind, and out of band. Inbound SQL injection is where the attacker sends the payload and receives the response immediately. In blind SQL injection, the attacker does not receive anything in the response from the server, so the attacker must rely on other means like Boolean conditions and time delays. And lastly, out-of-band SQL injection is where the payload is not directly triggered. Instead, the payload is stored and used later. Okay, so let's dive into error-based SQL injection, which is a kind of inbound SQL injection. Error-based SQL injection. As the name suggests, in this type of SQL injection, the attacker intentionally causes a database error, which is then shown to the attacker in some form in the UI. The attackers use the error message to either build their payload or extract data from the database. If the UI returns the code where the issue happens, the attacker can use that to construct their payload. That is a very simple example, but there can be other scenarios that help attackers to improve their payload. The error message may also include data that the attacker is looking to extract. The main causes of this vulnerability are, first and foremost, untrusted user input is used in a database query without proper sanitization or validation. Another important factor is a lack of error handling. As we have explained, the attacker tries to extract information using errors, which clearly shows insufficient error handling. And another related issue is that the databases include sensitive information in the error message that it returns. Let's move on to the union-based SQL injection. Let's first discuss what union is. Union is used to combine the results of two SQL queries, which normally are select queries. There are a few conditions for union queries to work. First, the two queries should return the same number of columns, and second, the type of the data returned in each column should be the same as the corresponding column in the other select query. Let's see a very simple example. What we are showing here is the payload submitted by the attacker. This can be in any entry point we discussed before. And as you can see, the attacker entered number 1 as the input to the entry point and then used union to construct their own query, followed by commenting out the rest of the sentence. Building the payload for this attack involves multiple steps. First, you need to confirm that the application is vulnerable to SQL injection, say by submitting a single code. Next, you need to find out the exact number of columns in the table you're trying to extract information from. We can achieve this using order by. As shown, you inject order by and then a number. As long as the server returns no error, you can keep incrementing the number. As soon as you get an error, that is when you should stop. The last number without an error message is going to be the number of columns. Then you can extract information. For each column, you put null. And you need to figure out which of these columns you can see in the error or in the UI. Once you find out, you can put your query in that column and keep the rest as null. It can get complicated to extract information and construct a payload, so we will not dive deeper into it at this stage. I will create an advanced video on SQL and we will cover it there. Now let's talk about blind injections, and our first type is Boolean based injections. As discussed earlier, in this type of attack there is no error shown back to the attacker. So the attacker has to be creative and come up with solutions to verify that something happened in the backend and in the database without seeing anything or receiving a message from the database. In this type of attack, the payload includes a true-false statement, and the attacker can infer information based on the results of the true-false condition. As an example, in 1 and 1 equals 1, both sides of that condition should be true. So we know that 1 equals 1 and 1 is probably an ID or something that is working fine. So we know everything is fine. But when we submit 1 and 1 equals 2 and an error happens or behavior of the app is not as before, then we know that our injection is working because the condition after the AND is not valid and the server is responding to that. Similar to what we have discussed, time-based attacks rely on adding a delay to the response that the server sends back to the client when a condition is met. Sleep and wait for delay are examples that can be used in this type of injection. Attackers can even use time-based injections to exfiltrate data. In the examples that is shown here, the server will add a 5-second delay if the first letter of the admin password is the letter A. Out-of-band SQL injection. In this type of attack, the attacker does not receive the response to their payload directly. Instead, they force the database to call the attacker or send a packet to the attacker with the information that the attacker is requesting. The database has out-of-band traffic permission, which allows it to connect to the attacker. So, in the example that you can see, the attacker will receive something like password.attacker.com, where password is the password for the users, as we have asked it to connect to that domain. This will be a DNS request, which is received by the server that is controlled by the attacker. And the final type of SQL injection that we are covering is second order injection. In this type of injection, the payload is stored in the database without triggering any vulnerability. Later, when the payload is read from the database, it may trigger the vulnerability. So the initial payload may not trigger vulnerability, but it is later used to construct another query, or it may trigger the issue if handled improperly. For example, the payload shown here will trigger the table removal later when it's read. Now let's jump into some hands-on lab to put our learning into practice. Okay, so let's jump into the first lab, which is SQL injection vulnerability in where clause allowing retrieval of hidden data. So before I jump into this, just for those who haven't seen my previous videos, for my videos I'm using Portswigger Academy as the lab environment, so you can create an account which is free and then access different labs from different topics. Okay, so this lab contains a SQL injection vulnerability in the product category filter. When the user selects a category, the application carries out the SQL query like the following. So as you can see, here it's selecting everything from that product and it filters based on the category, which is like if you go to the application or to the website, you can see we have different categories: all accessories, clothing and shops, and corporate gifts and gifts, right? So, and this is the ones that been used in here. And we have a released equals 1 as well. So that means it's potentially only showing only the categories which have been released or the products that have been released. We will see what does that mean and how will impact the number of items that we see. To solve the lab, perform a SQL injection attack that causes the application to display one or more unreleased products. Okay, so we know that basically the application is asking for gifts, and then it also checks for the release. So we kind of have to make the application to ignore this part, right? So let's go to our application. I've already set up the proxy, so everything has been proxied through Burp. Let us go and see all these products. Okay, so as you can see here, we see like 12 items, which are the products, all products that have been released, right? And if I go to each of these items, I'll see something smaller number of items. So if we go to Burp, to HTTP history, and then I go to the category, to this endpoint, send it to the repeater. Let's see the response. Okay, so here we see it, we have a filter, and then it says the category and based on whatever we input here, right? So as we discussed before, the first thing to identify if a SQL injection is possible is to add a single quote. Let's see how the server will respond. So the server is responding with internal server error, right? So now let's add a condition and say or 1 equals 1, 1 equals 1, and then we just comment out the rest. Let's see how, I'll just URL encode this, and let's see how it works. Okay, so this, you can see that actually it is working, right? So that means the web application is vulnerable to this sort of SQL injection. So what this part or what this payload is doing is that it says the category should be gifts or 1 equals 1, and then we are commenting out the rest. So that technically means that we are commenting out the release part as well. Okay, so now let's see how it works in here. You can see that we have the category and then it says gifts. If I add my payload here and then just have 2 of these, send it there, you would see that now I'm seeing more products, right? Okay, so that's gonna be this lab. Let's jump into the next. Okay, so our next lab is SQL injection union attack, determining the number of columns returned by the query. If you recall from the slides that we have discussed, we mentioned that you can determine the number of queries that are in a database using union and combining that with the null values. You just send the requests to the server and wait to see how and when the response from that server will change. So that is what we are going to practice here. The description says this lab contains a SQL injection vulnerability in the product category filter. So that's the same as before. So if we can come here, so you can see that we have like gifts. So that's my Burp. You can see that you can have, and then we have a product category filter in here as well. The results from the query are returned in the application's response. So you can use a union attack to retrieve data from other tables. The first step of such an attack, of course, is, as we have discussed, is to determine the number of columns that are being returned by the query. So let's put that in practice. I've already clicked on this, and let's go to our repeater to see what we can do here. So that's the filter that we are sending when we are visiting the gifts. So what we need to do is to create a union query and then select the different values and see how the server will respond. Union, and then select, and then we have null. Right, so that's our first column that we have determined. We just need to URL encode this and then send it to the server. We'll get an error. So let's increase this number to see if the table has 2 columns. Let's check if it has 3 columns. And there we get a response which says 200, and that is the correct or the change in the response that we were expecting. So if we go here, it says congratulations, you have solved the lab. So this lab been solved, but there is another lab in Web Security Academy, which is SQL Injection Union Attack finding a column containing text, which is the follow-up lab for this with the same thing. So I'm just going to cover this one as well. So let's discuss it. The way that it works is that in the previous lab that we've done, we found out how many columns the table has, and here we're gonna see which one contains text. So if you recall that we had one of the slides discussing the different steps, so this lab we're gonna cover the next step, which is finding the proper column. Okay, so moving here, so we'll send a payload or send a request to capture through burp and then send it to our repeater. So as we know, so we already have 3, and it is union, select, then we have null. Okay, and then we just need to URL encode this. Okay, so we get a 200, meaning that it works. And now we need to just replace these with some sort of random values. In the lab, it says make the database retrieve this string, right? So what we need to do is to replace each of these null values with that string, send the payload and see if that will address and solve the lab. Right, so we'll send it in the second one, and there we get a 200, right? So in the previous one we got a 500, and in the second we get a 200. So that means, if you recall, when we talked about the union, we said that we have to have equal number of columns, and then the type in the columns should be equal as well. So that means the second column in that table that we are reading from has a string or a text format, right? So now if we go to the lab, it would say we've solved the lab. Okay, so that's the second part of the second lab. Let's jump into our next lab. Blind SQL injection with time delays. If you recall from the slides, we have discussed that in blind SQL injection, you basically do not receive any error or anything from the server that shows or you can use as a proof that your exploit is working. So all you need to do is to rely on the behavior of the server and things like conditions or adding time delays to see how the server will react to your requests. Okay, so the lab contains a blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. The results of the SQL query are not returned, and the application does not respond any differently based on whether the query returns any rows or causes an error. So that is why we need to rely on blind SQL injection. We also had a little bit of a hint here, which is the cheat sheet for SQL injection, and we will be using that. Let's see what the cheat sheet is. Okay, as you can see, the cheat sheet, we have lots of SQL injection payloads, and if you go down, we have how we can extract the database version, the database content, conditional errors that we have discussed, and we have time delays. So we have, depending on the type of database. We have different payloads, and that is what we are going to use in this lab. Okay, so let's jump into the lab. Let's say how we can scroll. So we are intercepting the traffic through burp, and let's see how it works. If I go to the history, and then we have the life cycle. Oh, sorry, lifestyle. Okay. Sending the payload, and we get the 200. If you can see here, we have the cookie that we know from the description. This is the vulnerable part. And if we just try a single quote, nothing will happen, right? So that's the reason why it's gonna be a blind type of thing. So we are using a sleep function. So what we need to do is that we need to use the proper payload in here to see if we're successful, but we don't know what type of the backend database we are using. In a real world hacking or bug bounty, you might be able to guess that through different means. But in here, what we need to do is that we can try different payloads to see which one would be successful. And of course, this can also happen in a real scenario. Like you can try different variables, like you can try different payloads to see which one is successful. What we need to do is that we come here, we add it, and then we know that we have a slip. So this tracking ID has been passed to a select statement. So we already have a select statement, and then probably something like a selecting and where the tracking ID is this. And then we can remove this select, and because we already have one, and then we just say, or sleep 10 seconds, right? And then we we comment out the rest. So I'll URL encode this using Control U, and then let's send this payload to our application. You can see that the response is quite fast, and the vulnerability hasn't been triggered. Let's try a different payload. Okay, or let's see how this one will work. Okay, so it's still not working, but what I realized is that we probably should have concatenated our string, and then we also missing a parenthesis here as well, and then I can send this payload to the server, and you see that the server response has been delayed. So that's the reason why I need to add this, is because of the structure or the way that the database has been formed, that the query has been formed, and then you can see that we have a delay in here. Okay, so that's our final lab that we wanted to cover. There are more labs in Portugal Academy, more advanced labs as well. I will be covering more technical and advanced labs in the upcoming future. So we'll jump into our slides. So the last topic that I want to cover in this video is how you can protect your application and how to prevent SQL injection from happening. The first and number one prevention method is using parameterized queries or prepared statements. In parameterized queries, user inputs are passed as parameters, not embedded directly in SQL string as shown in these pictures. As you can see, instead of sending the input in concatenation, it is sent as parameters. Parameterized queries require developers to define SQL queries first and then pass parameters to the queries later. They can be used with the where clause and with insert and update statements. However, they can't be used when untrusted data is used with the table or column names or in the order by clause. The other method is the stored procedures, which are pre-compiled SQL code blocks that can be executed with parameters. Basically, this code block is compiled and then can be reused, so it improves performance as well. It's like a function in SQL. In the example below, the input user ID is treated as a parameter, not executable SQL. However, if not carefully coded, stored procedures can be dangerous. As an example, check this piece of code where concatenation is used in the code block that introduces SQL injection possibilities. So it is important to properly and safely code it. String concatenation is not a proper method in SQL queries, especially when dealing with untrusted user-provided input, so avoid it. The next protection method is to validate user input. Check for the length of the input. Say, if it's a state name, normally the input should be 3 letters, at least here in Australia. Check for format. You may also check for allowed characters. If it's a mobile number, then you don't need alphabets, only numbers. Another protection is to use whitelisting. In other words, allow predefined values to pass and block everything else. And another protection method is to follow the least privilege concept for the database account. This is important to reduce the impact of the attack in case of a successful exploitation. Using this, you can ensure that even if the attacker manages to exploit SQL injection, the underlying user account has limited capabilities. Okay, so we have discussed SQL injection in this video. We covered core concepts and different types of SQL injection. We also put our learning into practice by doing hands-on labs. Then we discussed how you can protect your application against SQL injection. If you enjoyed this video, please like and subscribe to my channel. I will be creating more in-depth videos on SQL injection. So stay tuned and thanks for watching.